Hello there, my name is Claes Eckerberg. Let's start with the sales pitch for CoClass. By using standardized digital objects and properties, you streamline the flow of information throughout the life cycle of the built environment. So, what does all this mean? How can we use it? First of all, let's start with classification as such. What is it? Well, classification is about objects, and an object could be anything, perceivable or conceivable, something you can touch or something you can talk about. It could be virtual or real. And obviously all objects have properties. So to classify is to group objects for a specific purpose. And a class then is a group of objects with one or more shared properties. It could be a group of people. You could call a class red things or cars. And you can divide cars into subclasses if you like, sports cars, family cars, saloons and whatever. And all these based on the need could be called classes. And what's it for? Why do we use classification? Well, basically you could say it's a tool to aid communication. To classify, for instance, plants. You can have local names, some Swedish names, British names, or English names, German names, French names, and so on. And this will be very difficult to communicate with all if you don't know all these languages, even Chinese or Arabic. But the Carl von Linnaeus invented the language of the Latin language for plants and gave them all a standardized description. In this case, primula means the first and veris means spring. So he called this plant the first of spring. And everyone familiar with the Latin naming of plants can understand what I'm talking about if I say primula veris. So that's the reason we use classification. And what about classification in CoClass? Well, it's about the built environment, as I said, and the primemost criteria for classification is function. What does the object have? What's the reason for having an object? What's its function? You can also use form or location or a combination of these. You can say, for instance, a function being a wall enclosing a space. You can have form, how it's constructed, if it's concrete or wood or whatever, or location. You can say this is an exterior wall or an interior wall, and you can combine them in a way, but you always start with a function. The classes are hierarchical, as I said. You can start by saying you have a space creating objects, and then you can go down to rooms, walls, roofs, slabs and so on, and you can subdivide as much as you want. And the classes are unambiguous. There's a unique class code and a class definition, and those are permanent. What name you put on the class is really up to you. It does not actually really matter. It makes it more easy to understand for a human being, of course, but the class code is the unique key to the classes. And this function criteria makes it actually you don't need as many classes. Very few classes if you compare CoClass with other international standards, but they are stable. You don't need to reclassify if you come up with a different technical solution, for instance, for a class. All those extra properties are not affecting the class, you might say. You can obviously add properties to objects, but the class is uniquely describing a function of an object. Well, of course you want people to be able to understand the classification. If you have the code, for instance, ULK slab plate That's the official name of the class. The code is ULK. And then you can add any number of examples, alternative terms for that class. So the slab plate could be a base grade, a bridge deck, for instance, concrete deck, floor slab, and so on and so forth. And this is important because you want people to find the classes based on the term, the word they use for that function in everyday language. One very important aspect of CoClass is that it's based on standards, but also the other way around. It can affect standards. We have this ISO 12006-2, which gives the principles for classification. The IEC 81346-1, principles for reference designations, identification of objects, and I will talk more about that later. IEC 81346 Part 2 have basic classes of components and built space. 81346-12 gives classes of functional and technical systems. We have the IFC standard, which is an international standard for CAD file exchange. And also we have the Building Smart Data Dictionary, which is an online dictionary where we hope to put CoClass, have it publicly available using the BSD functionality. Yes, so far this has been quite theoretical, you might say, but we also have a reality of built things. You have this building being under construction, and the data model for 81346 gives us this breakdown of the built environment. But you start with the topmost part being the physical, the actual physical things, you might say, and the bottom part is the process under the construction process and all the resources it uses. And resources then being construction products, obviously, goods you buy, construction aids, machines and stuff like that, construction agent, obviously needed, people, designers, architects, technical consultant, contractors, and of course people working on site. And also construction information is important, drawings, CAD models, etc. All these are resources put into a production result. We have the process with pre-design, design, production and maintenance. But it all starts with an organization that has a need for spaces. The user activity requires spaces to be built. And the built space is made up of construction results. It could be anything physical that is built or constructed in order to create that space. And construction results, there are three basic types. The construction element, the smaller parts, the walls, the windows, the road pavements and so on. The construction entity, which could be the whole building, the whole road, the whole bridge. And construction complex, a part of a city, for instance, a housing district or an airport, for instance. A number of construction entities performing a common purpose. You can also view it as a work result, and this is done using what is called production results. The Swedish AMA books are, for instance, an example of this, where we use work result, production results, describing how things are to be constructed. Another way to describe this data model is showing examples of all the tables that are included in ISO 12006-2 and in CoClass. We have activities, user activities, production activities and so on, and these are putting demands on the built environment. and then you can break it down to complexes, entities, built space, elements, element types, work result, the resources, and the maintenance activities. Currently, CoClass does not have a table for user activities. That's why it's pinkish in the image here. And we don't have tables for tools, labor, or products. And these will probably not be put into CoClass simply because there are too many ways of doing it. It's a too complex matter, and it's so much depending on the user needs and so on. So we'll see. Maybe we will evolve eventually into those areas as well. And yet another way of describing the concepts of this ISO standard. Some examples. You start at the top with single or dual family house area as a construction complex. You have the single family house, which has rooms. And as you see, all of these are coded AAA. And in brackets you have codes for showing what table we're in. So B is for built space, E is for entity, C is for construction complex, and so on. And then the built space is made up of construction elements, starting with functional systems, technical systems, and components. These are created by work results, for instance, layer of cardboard gypsum boards on indoor walls. This is an example of the ARMA code. To the left you see KBC 3211. So you can look up in the ARMA book and see how to build this wall. And in the bottom then you have all the resources, the actors, the production, the products, the tools, and the information, in this case in the form of a drawing. So the classification principle, I talked about function, and actually it's described or defined as an inherent function, what the objects do by themselves when they become occurrences. When things are used, they can be classified. Here we have a product, a pipe, and a pipe can be used for many things. But remember, this is an article, it's not a class. We have no classification for this pipe as a product. But we have it if you use it for scaffolding, for instance, ULD column and UMN horizontal rail. So when they become constructive things, they can be classified, in this case, then as ULD and UMN. But you can also use the pipe as a post, a UBD, defined as something that lifts something up and keeps it steady. You can use it as a stake holding a tree in place, but you can also use pipes to construct something, for instance a fence, RUA fence, a dividing, a blocking thing. And then of course you can use the pipe as a pipe, and the class WPA is called pipe. It's defined as a circular rigid thing with a flow inside of it. And we call it the class then pipe because that's the common word for it. But you could actually use any word you like for that class then. Well, the classes are very, in many cases, sort of theoretical. But for practical use, you also need types. And the type then is sort of a subclass, a collection, an object within a class, with one or more specific common properties. And CoClass has defined types of all object type tables. And if you need, you can also add your own. As long as you document it, you can add types as far as you go. So some examples, the class B wall system, the functional system. We have types for exterior wall, interior wall, shaft wall, and elevator shaft walls. And you can see then that B10 and 20 are types of B, and B21, B22 are types of B20. So it's a type, you might call it then. You have the wall constructions, AD, with solid core, and then types solid core of cast in situ concrete or sliding form cast concrete. And a beam. Sorry, the image now is blocking. ULE solid beam, and then subtypes of different kinds of solid beams. And CoClass is based on international standards, and standards exist in virtually all areas around the world. National, local, industry standards, de facto standards. There are a lot of kinds of standards in this sort of a hierarchy. In Sweden we have these organizations working with standards, starting with SIS, the Swedish Standards Institute. On the international level, then you have ISO, you have CEN on the European level. Then for the electrotechnical side, you have SEK, which is the Swedish Electrotechnical Committee, and IEC on the international level. Then organizations like Building Smart also produce standards, IFC for instance, which in its turn can become international standards. So IFC is now an ISO standard as well. On the geographical side, you have OGC, the Open Geospatial Consortium, producing standards for GIS data and so on. And the interesting thing is that even when you limit the standards to the built environment, there are many ways to do it. You have already seen that CoClass classifies a pipe as a WPA. You can't find it as a construction element in BSAB system. Uniclass, you can define that this is a water supply system, and there's also a product class for steel pipelines which might be used here. But you see that differs very much from CoClass' very simple definition of the pipe. The same goes for Omniclass, the American standard, which has a class then for the underground single wall pipe. So very detailed on that level. You can't find the pipe as a pipe on a more generic level. And in IFC, it's very generic. It's a flow segment. And in the Swedish system BIP, which is a very pragmatic way of assigning codes to objects, V1 is the code for water pipe. V is then for the Swedish word vatten. Water is spelled with a single V. So there are many ways, even though you have a standard. Sometimes you can translate between them, but often it's very difficult. And that's why I think CoClass works so well, that it's always stopping on a generic level. And the properties that this pipe is of steel, it's single walled and so on, that is much better described using properties. Which leads to my next slide. CoClass has some 750, 800 properties as well. They are classified as well. Here you see some examples of material properties, the next level functional, and then acoustic properties. And then you find the actual properties, AC, sound absorption coefficient, and so on. Here you see that the code has meaning, which is not according to more strict classification rules. But in this case, we find it practical that you can see that AC stands for some sort of acoustic property. In the column attribute name, you see the proposed attribute name that should be used in BIM software, in CAD software. CC sound absorption coefficient, for instance. Then, if possible, we also have a source, in this case a European standard, the type of value it is, and so on. So these properties can then be assigned to objects, and which object to assign or useful, that varies very much through the life cycle In the pre-study, you don't need much, you don't know much, so there are very few properties. But as planning, design, production goes on and use, the number of useful properties grow. But they're not always the same. In production, you need different properties from in the use, for instance, and in the decommissioning. In the decommissioning, you still perhaps want to know the material, but how it was produced and so on is of less importance. And one property that is very consistent is the class of the object. And if you use CoClass, as you see the red rectangles on the bottom, that would represent the class property. And the next one, the green one, being reference designation. I will talk more about this later, the unique ID of the object. And a product ID could also be useful. That could be, for instance, a serial number of a machine you have bought and so on. And that product will, or that property will change during the use. The use phase is often long. It might be 10, it might be 100 years. So the actual product might be switched if it's broken and so on. So you can have different product ID depending on where you are in time. But the class and the reference designation stay the same. So CoClass also proposes how you describe the life cycle of the properties. This is based on an IEC standard, where it's called. Well, they have a standard for the life cycle then. So SPE is for a value that is specified, INQ for inquired, OF for offered, and so on. So if you label the properties, you can then see that a value perhaps changes. So if you see the, I will make my pointer more visible. There you go. The specified properties in this case for the door is the width should be 900 and the material should be oak. But the supplied properties, the contractor actually bought a door which is 1000 wide, still useful then, but they changed the material to Gabon. But if you have a database and storing properties throughout the life cycle, you can always go back and see what properties were specified by the designer, by the architect, for instance. And this is important to keep. If you have to rebuild something, it's always good to be able to go back to the specifications, what the original requirements were. So moving on then, making this hopefully a bit more concrete. With CoClass you build structures describing the built environment. So you have all these tables, the construction complex, the entities, the built space, the functional systems, the constructive systems, the components, and you add them as you like, depending on what you are trying to describe, of course. So an office building would typically have a number of functional systems, being the ground, the walls, the slabs, the electrical system, the transport system with elevators and so on, lighting, security arrangement, all of that. And these are, of course, the basic functional properties of the building. And this is where you can stop if you want to have the building erected. You can stop on this level, defining your requirements and say, I want the roof be of this kind, I want the automation system of a specific kind, and so on. You don't need to get into any more detail. And the same applies if you have a road. Fewer systems here, but obviously you have a ground system which compromises of the road as such. You have drainage waste, electrical, automation often, you have lighting arrangement and traffic arrangement with roads, traffic signals and so on. So to be more concrete, the wall example then, you have the entity, for instance a hotel building. You have functional systems, in this case B10 exterior wall and B20 interior wall, the numbers then being types of wall systems. Both of them have a technical system, or constructive system as we call them. In this case AD10, a wall construction with a solid core for the exterior wall, and AD30 wall construction with the truss core for the interior walls. In both cases, obviously, you need components, and both these types of walls need a wall plate, the rigid shape in the middle, making the wall strong, so to speak. So they both need wall plates. But they are made up of different work results. So in ARMA you can go and see ESB22, how to build the mold, how to make the reinforcement, and how to manage the concrete being used. But for the wall construction with the truss core, you need other production results showing how to make the wooden frame being the wall plate in this case. So it's a timber frame wall. So here you see one example then of two different kinds of constructions in a building. You have this 1, 2, 3 step, B for the function, AD for the construction, and ULM for the component. And obviously the wall would need more components, insulation, wall covering, and so on. And you can get a complete code describing the object, the systems and the production result, which is shown here in parentheses. And the road example, you start with the construction entity being a road. You have spaces for the carriageway and the shoulder. So in this case, the construction is defined by the space needed. So it's a bit different from a building. But you still need the functional system. In both cases, it's a ground system. You need technical systems, still being the same here, flexible ground superstructures. But on the component level, in both cases, you need a paving. But the work results needed are different. The paving is by asphalt, but the shoulder then does not need the asphalt. It's simply rock dust. So very similar structures then for describing the carriageway and the shoulder. The only difference being a different work result, different material used. So what we do in CoClass is make, sometimes it's called a digital twin, even I don't like that term though. A digital twin, in my view, is a computer model of a building, for instance, but the computer model has sensors reacting to the world, so sensing temperature, wind, solar, sunlight and so on, and it's then affecting the building, so making the building react to input from the environment. In that case you have a what I would call a digital twin. In this case it's a model, an information model built up using CoClass. And CoClass then gives standardized classes of objects and property names. So for instance, the door can be described using the class code, the name, the type, the width, how it's maintained, and so on. And please observe that class is also a property. the object in itself is just an empty container, digital. It's a row in a database, you might say. So class is the premier property for describing the function of the object. So it's a very important property, but it's still just a property of a virtual object in a CAD environment, for instance. But you can then connect, add more properties to the object. So in this case it's a wall covering. You have the material property, the type, referring to an ISO standard in this case. You have the work result code. You can have a type ID. In this case it's from this BIP code, where the G simply stands for gypsum board. You can have a resource definition. In this case it's a link to the Building Smart Data Dictionary. I'm not sure if you're familiar with that, but it's an online ontology, a dictionary for everything relevant in the construction industry. And you can also refer it to product catalog, in this case using ETIM. And ETIM also has a lot of properties describing, in this case, a gypsum board. So you don't need everything in your own database. You can always refer to other sources hopefully using the code for, in this case, a wall covering and the gypsum board. And you can extend this even into the production phase. If you have decided that you need a gypsum board, you can then connect it. You can find actual physical products meeting your requirements for the width, the length, and so on. And once you find a product, you can have a lot of data then referring to that actual product. You have the GTIN number, the global trade number. You have the GLN, which is the localization number, actually the number of the factory in this case producing that gypsum board, so you know where it's produced. And you can also have a GT number for a 40 pack of gypsum boards, and you can have prices and weights and if it's in stock and so on. So here you see the complete flow of information from the requirements down to buying the actual product. And again, what's connecting them is the CoClass code and the standardized properties used for describing it. So this means that you can have many applications, many uses of CoClass. Obviously for classification and structure. Identification is important, I will talk more about that. Hierarchical requirements. You can put requirements on a high level, and then you can follow this up during the whole life cycle. We can use it for cost calculation and product planning and delivery. I'm currently working with one of the largest Swedish contractors, trying CoClass for detailed production planning. Technical specifications, the production results, and the ARMA codes is an obvious use for CoClass. Once you connect production results to the objects, it's easy to produce the technical specifications. Finding articles is a growing industry. Svensk Byggtjänst has a product catalog, and many others exist. There's one called sorry, forgot the name now. It's a service where you can find the environmental properties, miljövarubedömningen, sorry. It's a service where you can find environmental properties of products, and they will start using CoClass now, so you can find, for instance, the wall covering, the pavement and whatever, using CoClass to find the articles that have the least environmental impact. You can use it for translation. connected to BSD, for instance, environmental databases, as I said. Operation and maintenance, you can connect maintenance activities to the objects, and this will be based then for the janitor taking care of the building, for instance. And decommissioning, once you need to tear the building down, if you have a good information model structured, you can then find information about what materials are used and what to do with the waste and so on. So I'm actually currently preparing a new table for waste classification that also can be used in CoClass. So you can describe the building and see what to do with it once it's no longer needed. And in that sense also, of course, the circular economy, reuse of objects. I'm also involved in a project dealing with that kind of thing, how you can classify things and describe things for reuse. So if we go back to the ISO 12006 standard, you might recall that we start with the activities. In this case, you need a place to sleep. In order to do that, you need a built space suitable for sleeping, a room. And you can put it in all the spaces in a single family house, which is then located in a single or dual family house area. These are work results. These are the actual products from the construction process. You can also go more into detail. The built space is made up of construction elements, starting with the functional system, the technical system with a specific type of construction, and the components, a wall plate and the wall covering. These are construction elements of 3 different levels. And again, you have resources, you have the actors, you have the tools, you have the information, and you have products. And these end up being work results. So when you use ARMA function, for instance, to make the requirements needed for, in this case, the single family house, you start by putting requirements on the built space. How big should it be? Air change rate, coating, daylight, electric lighting, and so on. You have requirements also for the whole building. How many rooms, the architecture of it, of course, the energy use, how it's maintained. The life cycle cost, for instance, very important at this level. And if you're a city planner, for instance, you obviously need requirements for the housing area in this case, where it's located, how much traffic is it, what kind of microclimate is it, and so on. So you can use CoClass on all these levels, having standardized properties for requirements. So to be more specific then, the interior walls need insulation, the material, the coating, cost of course. The structural engineer needs to put requirements on the structural, the strength of the wall, the recipe, the cost, how to build it. And the components then, what types of materials, the cost, is it in stock, and so on. And this methodology is then used in the new ARMA function. You might call it CoClass for turnkey contract, for instance, in Swedish totalentreprenad, where the owner, the client wants something built and put requirements on a very high level, and then use letting the contractor decide on what technique to use and so on. So you start putting requirements on the project level. Administrative properties, for instance, how much energy use, what the architecture is like, and so on. And you have construction entities in a project, for instance, a building. Again, energy properties, the architecture, and so on. So if you need, you can put requirements also on the functional systems. You perhaps have a specific requirement for material on the facade or kind of energy used and so on. There are technical systems and there are components. So the requirements are inherited from the project level all the way down to the components, if you like. And of course you have the spaces, and the spaces also contains functional systems, and it's made up of functional systems. So if you have put requirements on this level, those requirements are also valid on this level. And the same goes for the technical systems and the components. So it's a very intricate, might look complicated in the beginning, but we hope that it's logical, that requirements are inherited all the way down. And the client can decide for him or herself on what level to put the requirements. Sometimes it should be as high up in the hierarchy as possible, but sometimes you need to have very specific requirements down on the component level. So this is a brand new product, ARMA Studio and ARMA Function. So it's been released now for a couple of months, and we have a number of pilot projects going on now. So this will be our own first big use of CoClass. So we're very excited about this and hoping that it will be a success, obviously. As you know, there's a ever-growing importance of the environmental impact of human activities, and the built environment plays a large role in this. We need to start limiting the way we affect the environment. Everyone knows this, and I think the construction industry is starting to take responsibility for this. And actually the environmental issue is now a driving force for the digitization of the construction industry. There's so much data, in order to keep track of it, you need, I would say, to be more digital. So I've been involved, and still am, in a number of research and development projects dealing with environmental impact. There's a new Swedish law dealing with climate effect. So in this case you can use, or one example is using CoClass then for life cycle analysis, LCA. You need, of course, then to have, you need to know the data of the resource use, and how the material used is affecting the climate, in order to produce the climate declaration, how many kilograms of carbon dioxide is produced. So together with IVL, Environmental Institute, and others, we are starting to make up an environment data hub, the building sector data hub for environment. And the unique selling point for this is quality control data. Obviously the producer of materials and products need to be able to declare the products, but that is not always possible. So then IVL and others can help in producing data showing, if you say, for instance, again, the gypsum board, how much carbon dioxide is produced, and what other wastes do you have from the production of that product. And in these kind of calculations, you also need to calculate the energy use for all the transports, for the production itself, and if you like, also energy used in the maintenance, the use phase of the building, for instance. So I won't go into detail in this presentation about the use and the solutions we are sketching on. But I want to emphasize is that I would say that CoClass again has a unique way of defining and describing the built environment at any level you need. You can start with the whole building, for instance, and have sort of recipes for that, and you can go down to the very small details, all of the construction elements in the building, which is of course important. So CoClass then will be one source for this. We have a coming table for materials, for resources and materials. You see in material and type we have a code for that as well. So these are classified, or at least grouped, and given a code for the material. And all of these are also put into the Building Smart Data Dictionary, so you see the links to that, which means that everyone using these tables can have a common source, a common definition of that material, which is important if you want to have quality data. So, sorry about that. You can have all the measurements needed for making the calculation, then the volumes, the weight and so on of different materials. So we have a tool in CoClass called Cochlear Studio, and in this tool you can put in the information model, you can make the structure describing your building, and also add values. You see marked here 41 square meters of a hardscape area. In this case it's for a schoolyard when we tried this methodology. So the landscape architect made a information structured description of the schoolyard, put in all the construction elements and all the values for all the measurements, and these were then exported into a calculation software. And again, I remind you of this. You have the generic resource, which you can connect to actual product data using an environmental product declaration. So this is not complete yet. We are still sketching it, you might say, but I would say that hopefully during this year we'll have a finished project description of this, and finding a standardized way of making these environmental calculations. I'm very much looking forward to that. And now the last part of this presentation is the very important use of CoClass for identification. CoClass obviously classifies objects, but you can also give them unique numbers. So you can number each individual object in the building, for instance, as detailed as you like. So this is based then on 81346 Part 1, the international standard. I mentioned that in the beginning. And I think this is a good way of describing the relations between the digital model above the horizontal line and the physical implementation. So you start with the pre-study. You make a decision. Yes, we will complete the project. You start with the planning and define all the requirements needed. Then the designer gets started. Let's say this is a ventilation system, and the designer starts designing, making his or her systems and components and so on, adding data to them, and starting to give them a reference ID. So in this case you can say that, say for instance, that these are pumps or fans in a ventilation system. So then you can number them and saying this is fan number 1, number 2, number 3 in this system. So in this specific building, each of these fans is given a unique number. Then of course someone has to produce the actual products being used. And the product also has data. The manufacturer has a lot of data describing the product, including a product ID, perhaps a serial number or a product number from that manufacturer. And of course on the bottom you see the actual physical product. And during construction then, the data from the designer are combined with the data from the product. And the build system contains 3 of these objects, say fans or pumps or whatever, and also one extra, a spare component, which is kept just for maintenance purposes. So the standard calls them occurrences, the components that actually are being used. But there are 4 individuals here, 4 individual products. Oh, sorry. And then in use, the 4 individuals, one of the components is broken. So then the spare component is used, and you need to buy a new component, a new spare. But if you keep track of the design data, you can hopefully find replacement objects. And the original data is also important in the decommissioning. So the occurrences then are defined or described using this reference ID, and it's a very strict and logical system defined in 81346 part 1 and part 12, with the components, the occurrences and so on. And you can classify using different aspects. The type aspect showing, for instance, what type of window it is, the function, saying simply that this is a window which is defined as a light controller. You can have the product aspect showing you that how it's assembled, that the window is a part of a wall, which is a part of a wall construction, which is a part of a wall system. And you can also describe the localization and the position. So you can say that this window is in room number so and so. So combining these, using all these aspects, you can get a very detailed description of every object in a building, or any construction entity. So one example here then, this light fixture is placed in AQA10, passage number 10. It's part of the lighting system number 1. It's part of the lighting supply system number 2. And it's a light fixture number 11. So the equal sign then shows the shows the sorry, I will get to this one later. This shows the identity of this light fixture, and then the percent sign shows the type, saying that the lighting system is of type general lighting. The HH, the lighting supply system, is electric, and the light fixture is type 09. So, using reference designations, you can describe the objects to any level needed, and this is, of course, very important throughout the life cycle of the object. The placement AQA can be used by the contractor, knowing that this light fixture should be placed here, and also for the maintenance people finding it. You can find all light fixtures in this passage, for instance, so you can find all light fixtures of a specific type. So the possibilities are almost endless, I would say. This way of describing objects using reference designations. It's been used for many years in the electrical industry, and now it's starting to spread in construction as well. And I think that is one of the most important aspects of, or the most important uses of CoClass and 81346. So I've come to the end, finally, 54 minutes as I see it. I hope, I'm sorry about my voice, which hasn't been really consistent, but hopefully you've got an overview at least of CoClass and modern digital way of identifying and describing objects. If you like to send me questions by email, please feel free to do that. I will answer them as much as I can. And I'm sorry I didn't get the chance to meet you, but well, hopefully this was better than nothing. So thank you very much for your attention, and good luck in your future studies. Thank you very much.